here. All right, so to figure out percent composition, we're going to take the part, whatever that is, the mass of the element in this case, and divide it by the whole mass of the compound, and then multiply times 100 to arrive at a percentage for that element. Now, you can be asked to find the percent composition of a specific element in a compound, or if you're told to do the percent composition of the entire compound, you'd find a percentage of each element present in the compound. Okay, first step for this problem is going to be figuring out what potassium chlorate even is. So potassium is K, and then chlorate is ClO3. What type of compound is this? Okay, yeah, I'll get polyatomic. So it's got polyatomic ion and a metal in it. So what type of compound is it? Ionic, yes. All right. That one's positive. That one's negative. Hopefully you know this. And if you don't, that's in group 1, so it's +1. And that's polyatomic ion that you should know. So when you put those together, the formula is... All right. Great. So we know the formula for the compound. Now, I could ask you, tell me the percent potassium in the compound, or I could just say determine the percent composition, and either way you could figure that out. Now, if we're doing this in lab, we might figure out do some kind of experiment to separate one of the elements from the others. Like it's pretty easy to separate the oxygen from the potassium chlorate. Do you remember when we burned the gummy bear? Yeah. So all you have to do to get the oxygen to separate is heat it up, and that'll make the oxygen leave. So you can figure out the percent oxygen in that just by cooking all the oxygen off. So you do the oxygen mass divided by the total mass of the potassium chlorate if you're trying to do this experimentally. Now, if we just know the formula and we want to find the percent composition of each element, I'll show you how to do that right now. All right, so there's 3 different elements, so we're going to have to repeat the solve process 3 different times. And I'll specify that I'm solving for the percentage, just so you know. All right. Yeah, sure. Oh, yeah, that's just the equation again. Part divided by whole times 100. All right. We've already added up the mass of this compound before. And that's back here somewhere. Oh, yeah, there it is. Okay, so we added up the mass of the KClO3, and its molar mass is 122.6. And maybe you remember that the way we got that is we added up 39.1 and 35.45 and 3 times 16 to get the total of 122.6. Now, what part, so when we're doing the part over whole thing, what part of this 122.6 is potassium? 39.1, yeah. So that's the mass of the whole compound. That's the mass of the potassium in it. Again, if you were doing lab, you might have a procedure that would enable you to figure out how much potassium is in a sample. So it wouldn't have to be over 122.6. It could be like you have a 5-gram sample, and then you figure out how that might be your total, and then you figure out how much potassium is in it and divide that by the total. So the one thing that's missing here, I haven't put the times 100 on there yet. Setup for the chlorine would be similar. It's going to be the 35.45 divided by 122.6. And then the oxygen, and just to make sure nobody's wondering this, why did we do 3 times the oxygen mass? Yeah, there's 3 oxygens in the formula. Sure. All right. All right. When we get done with these, what should all the percentages add up to if we did this correctly? Yeah, about 100. Okay. All right. So 39.1 divided by 122.6. Is anybody times 100? Anybody got that one yet? $31.89. Anybody second that? Okay. I'm just going to go to 3 significant figures. All right. 35.45 divided by 122.6. 28.9. Second. Okay. James, have you actually done those, or are you just? Yeah. Okay, cool. All right, and then the last one, hopefully about 40. 39.2. Second. Okay. And I think that actually checks out to, yeah, that's adds up to exactly 100%. All right. So this would be the result that you would expect from an elemental analysis. So if you take a compound and you break it down and into the elements that it formed from, you might get something like this that tells you that the compound contains this percentage of potassium, this percentage of chlorine, this percentage of oxygen. We're going to be able to use that in reverse to figure out the formula when we do the empirical formula stuff later. So you can go from this to empirical formula, or you can go from the formula to the percent composition, which is what we did. We went from the formula to the percent composition, but you can also go from the percent composition to the formula. All right. Do y'all need that for a second, or are you good? Okay, I see writing, so I'll pause for a second. All right. So this is another application of percent composition, and you're going to do this with the lab as well. So a hydrated compound is a compound that contains water in the crystalline structure of the compound. There are quite a few compounds that do this. Epsom salt, which is magnesium sulfate, it contains waters of hydration. The alum crystals that you made, they contain waters of hydration. Let's see, I'm drawing a blank here, but yeah, there's quite a few compounds that will contain waters of hydration. And then if you see the term anhydrous, that means that it's the same compound without water. So for example, in this 10,2 chloride dihydrate that you see down here, if it was just 10,2 chloride without the water in it, then we would say that the 10,2 chloride is anhydrous. Now, how do you remove water from a pot? Like if there's water in a pot, what do you do to remove the water? Aside from pour it out, what could you do to it? You could boil it, right? Okay, same concept with these compounds that have water in their crystal structure. If you heat them, then the water will come out of them. What would be some evidence you might see as a result of that water coming out of this compound, like if you heat it? Difference in mass, yeah, it would weigh less afterwards. What else? What kind of sounds or sights go along with boiling water? You might see bubbles, you might see steam, you might hear as the water's cooking out of it. Okay, all of those things. So you'll see that when we cook the alum crystals later. Yes, unless you didn't make any crystals, and then I'll give you some alum to cook.
We're cooking crystals.
We're cooking crystals.
I'm so excited. I've been waiting
All right.
for this since day one. Why didn't you tell me whenever I asked you?
All right. So yeah, let's do our 10-2 chloride. We got to write the formula for that. So the 10-2 is definitely doesn't have a T in the formula. It's SN. The 2 says it has a plus two charge. All right. So what's the formula of the 10-2 chloride? SnCl2. And then the dihydrate means that there are 2 waters. And remember, you can write it this way or you can write it this way. And just do whichever one is less confusing to you. Okay, so SnCl2 times 2H2O. By the way, that doesn't mean you multiply anything. That's just another way of showing, it's just a way of showing the separation between the water and the compound, or you can show it this way. All right, now, so our unknown, we want to know percent composition of what? Water. Which is nice because we don't have to do, like when they just say percent composition, you have to tell the percent composition of all the elements in the compound. If they tell you which one to do specifically, just do that one. So we've just got to do the percent composition of water. We know the formula is SnCl2. Which way do y'all like better? Y'all like the parentheses better?
Yeah.
Okay, I'll do that then. All right. And then, let's see, plan. Oh, it's the same thing. We're going to do the part over the whole times 100. So let's solve. Okay, what's the part of this that's water? H2O. How many of them are there? 2. Anybody remember the mass of water? We've already added it up. 18 point something, yeah. Oh, yeah, we added it up over here. It's 18.02, right? Okay, so that's the part water. But I'm sort of kind of forgetting something on purpose. Times it by 2. All right, and then what do I need on the bottom? Part divided by whole. So I need, okay, when you say the rest of it, do you mean the SnCl2 or do you mean all of it? All of it, because we're saying part out of the whole. So we're going to do all of it. So the 10, the chloride, and the 2 waters. Let's see. 10's mass is 118.7. Then 2 chlorine's 35.45 times 2. And then 18.02 times 2. I'm going to pause the recording. All right, so we got 15.9. What's the unit that should go with this? I think I heard it. Okay, yeah, there's H2O, but there's something else. Percent, yeah. All right, so we figured out the part that's water out of the whole compound. So that's how we would show it. So good job, and that's how that works.